So in this video, I'll demonstrate the process of solving dimensional analysis. So these are the steps for solving dimensional analysis. You want to first identify what's given and what's needed, and then determine the relationship between that two. That relationship is shown as a conversion factor. My recommendation until you get real comfortable, especially for those that do not like math, go ahead and show both ways that the conversion factor can be written out so that when you move on to the next step, which is utilizing the given measurement along with the conversion factor, in order to cancel the units, you'll know which form to actually utilize. From there, once you have everything set up and the given units are canceled so that you're left with the needed units, you simply carry out the calculation and then round it based on the rules of significant figures. So I'll go through the steps as I explain this example. And so the example has us converting 420 centimeters to meters. And the first thing is to identify what's given and what's needed. So what was given is the 420 centimeters. What's needed are the meters. And so once you know that, then you can ask yourself, what is the relationship? Or is there a relationship? And there is a relationship between meters and centimeters. So meter is the base. Centi is one of the prefixes that indicates a factor of 10, in this case, smaller than the base. And so if you recall, centi is 100 times smaller. So that means we do have a relationship between those two units. So we can go from the centimeter to the meter because there is a relationship and we know that this is what was given and what's needed. We can identify the conversion factor. The conversion factor simply shows the relationship between the two units. Centi is 100 times smaller, and so we can show it as it's currently shown, which allows us to simply focus on the meaning of the prefix. The meaning of the prefix is 10 to the minus 2 of whatever that base is. So if you do it this way, you'll notice that the meaning of the prefix is with the base unit. The prefix itself is on the opposite side. So if this way is too complicated, you can utilize the actual meaning. So how many of these items are equivalent to one of another? In the case of the prefixes that are smaller than the base, such as deci, centi, milli, micro, those are smaller than your base unit. We can indicate how many of those smaller are equivalent to one of the larger. So in the case of centi, because it's 100 times smaller, that means that there are 100 centimeters in 1 meter. So I can show it either way. So technically there are 4 different ways I can show this conversion factor, and they all represent the same way. So whichever method you are more comfortable with, that is the method that you should utilize. So once you've identified what was given and needed, you now have your conversion factors as well as the plan for how to go from those units. Now it's time to arrange everything so that you're starting with the measurement that was provided, but you're utilizing the conversion factor that will allow your units to cancel. So even though we came up with these multiple conversion factors, not all are going to be used. Again, you can choose which form you would like to utilize. And the reason why I recommended showing multiple is so that you can then look to see which form is needed. So recall in algebra, in order to cancel the given unit, we need, since we're starting with centimeters, we need to divide by the centimeter or have centimeter in our denominator. So in order for units to cancel, they must be in the numerator and denominator. So when we're starting with this unit, that is our numerator. So we need centimeter in our denominator. So that means that we can then choose which conversion factor we need to use to cancel the centimeters, which would be either of those on the right. Again, it doesn't matter whether you use the top option or the bottom option. Whichever method you prefer, they're both going to give you the same answer. So once you know which conversion factor allows your units to cancel that you no longer need, that is the conversion factor that you will then utilize when arranging your dimensional analysis calculation. So now that we have our given unit and we have our conversion factor, again, if you chose the opposite one where it shows 100 in the denominator, that is fine. You're still going to get the same answer. And so once you have everything set up, you have everything arranged as it should be, you then want to carry out the calculation. Everything in your numerator should be multiplied, everything in your denominator should be multiplied, and then you're going to take the product of your numerator divided by the product of your denominator to get the answer. And so you always want to keep in mind the rules of significant figures. We were only provided one measurement, which was 420 centimeters. And so that number, as it was written without a decimal, only had two significant figures. So your answer should also be reported with two significant figures because we only multiplied and divided in this problem. And so our answer would be 4.2 meters. So let's try one more before we get into a more complex example. So here you're asked to convert 36,500 grams to kilograms. So you still want to go through the process. As you get more familiar with it, you don't have to necessarily show each individual step, but while you're learning it and until you get comfortable with it, my recommendation is to show those extra steps. And so we want to first figure out what was given and what was needed. So 36,500, that is our given, and what we need is the kilogram. And so from there, we can ask ourselves, is there a relationship between gram and kilogram? And we know that there is. We see the gram in both. Kilo is one of the prefixes, meaning 1,000 times larger. So we know that we learned that there was a relationship between the two. So again, we can show it two different ways. We can show it where we have 10 to the 3 grams is equivalent to 1 kilogram. Or I could have flipped it and had 1 kilogram over 10 to the 3 grams. If you prefer not to utilize scientific notation, you could have also shown it as 1,000 grams is the same as 1 kilogram, or 1 kilogram is the same as 1,000 grams. Either one that you decide to use is fine. So we know our given and needed units. We know that there is a relationship. We now have the conversion factors. So now we can start to arrange our conversion factor to cancel out our given unit. So you want to start with the measurement that was provided, 36,500 grams. I'm going to do the T-chart just to show it two different ways. So previously, with the previous example, I showed with the parentheses and the fraction. They mean the exact same thing. It's just quicker to draw out this T-chart. And so previously, the next step was to identify which conversion factor we needed. So we still want to do that process. So in order to get our given unit to cancel, we need the gram to cancel. So right away, what that tells us is we won't use this one because it has kilograms in the bottom. We won't use this one. It has kilograms in the bottom. If we use those the way that they are arranged, our given unit will not cancel. So that leaves us with our other two options. Since I used the scientific notation method in the previous example, I'll do the standard notation method in this one. And so once we know that we're going to be utilizing either one of these, they're both going to give you the same answer. But once we know that, we can then plug that and use that in our setup. So the recommendation that I generally give is to focus on your unit, but since we went through this step, we already know which conversion factor, but you still just want to make sure that your proper units do cancel. And so my grams will cancel by putting it in this way. And so I have 1,000 grams for every 1 kilogram. My grams have canceled, so once I carry out my calculation, the remaining unit, which is what I needed anyway, is going to be the kilogram. So from there in your calculator, you will have your 36,500 times 1, which of course is still 36,500. You're going to divide that by 1,000, and in your calculator, it's going to give you 36.5. Again, when you're carrying out mathematical operations, check your math, look at what the calculator gives you, then go back and think about your rules of significant figures. In this problem, we were dealing with 36,500. There was no decimal provided, so based on how this was written, our given measurement contained three significant figures. So our answer should have three significant figures. So what we have is the converted relationship. So what this tells us is that 36.5 kilograms is the same as 36,500 grams. Some conversions are simple and direct. You only need one conversion factor to go from what's given to what's needed because there is a direct relationship between those two units. However, that's not the case for every conversion. Sometimes we don't have that direct relationship between the given and the needed units, so we have to figure out something else that they are both related to, and we call that an intermediate unit. So we may have to incorporate one intermediate unit, we may have to incorporate multiple intermediate units, but this guideline is still very similar, pretty much the same. It's just that now we have to incorporate additional conversion factors. So you still want to start by identifying the given and needed units and then ask yourself, is there a direct relationship between the two? If there is, there's going to be a direct or a single conversion factor. If there is not, then you have to ask yourself, is there another unit that they both individually have relationships with? And so if there is, then we want to use that unit as the intermediate unit. Once we've determined how to go from given to needed with the help of that intermediate unit, we then want to determine all of the different conversion factors that are available. Again, we can show them as two ways. This is an optional step. If you're still not comfortable, I recommend to do it, but it's not a required step. Once you have your conversion factors and you know the roadmap, essentially is what I like to call it, to go from the given to the needed unit with the help of the intermediate unit, you then want to set it up starting with your given unit and then arranging all of the different conversion factors that will be used so that you can cancel out any given units as well as any intermediate units so that you're only left with the needed units. From there, you're going to carry out the calculation and then round based on the rules of significant figures. So we'll go through an example as I go through the steps again. So in this example, we're going to look at converting 0.084 days to minutes. So again, we want to start by identifying what's given and what's needed. So what we were given were the days, but what we're needing are minutes. And so if you know the direct relation between days and minutes, then feel free to utilize that as a conversion factor. Feel free to go straight from days to minutes. However, not everyone knows that direct relationship, but what they do know is that hours are related to days and hours are also related to minutes. So in other words, hours can serve as our intermediate unit because there is a direct relationship between our given, which is days, and hours, as well as our needed, which are minutes and hours. And so we can plan to go from days to hours and then from hours to minutes. And so the way that we map out how to approach converting our given to our needed, we can look at that and help to guide us through the problem. And so if you notice, I have days, then I have an arrow showing that we're converting days to hours, and then hours, and then an arrow because we're converting hours to minutes. Everywhere you see an arrow, so a conversion means that we're going to need a conversion factor. So I need a conversion factor to show the relationship between days and hours, but I also need conversion factors to show the relationship between hours and minutes. And so we know that there are 24 hours in a day. So on the left side, I show the two ways we can show that relationship. I can show it as 1 day over 24 hours or 24 hours over 1 day. We're going to use one of those. And then I can show the relationship between minutes and hours. There are 60 minutes in an hour, so I can show it as 1 hour over 60 minutes or 60 minutes over 1 hour. Again, we're going to use one of those. So once we know the plan, and again, we can call that the map, it can help us with arranging our conversion factors. So we know we're going from days to hours, hours to minutes. We always want to start with the measurement that was provided, and what we were provided was the 0.0084 days, but we need to convert that to minutes. Before we can go to minutes, we need to go to hours. And so based on our two arrows, we know we're going from days to hours, so that's one conversion factor, and from hours to minutes, so that's our second conversion factor. So we have to identify which of those conversion factors we're going to use. So for the first portion, and so these are the same four from the previous slide, but instead of writing them out horizontally, I'm showing them vertically, right up under the question mark that they apply to. The first portion of this conversion, we're going from days to hours. So I need to utilize the conversion factor that would allow my days to cancel so that I'm left with hours. And so in order for my days to cancel, I need days in the denominator because that's what I currently have in my numerator. So I have to have numerator and denominator same unit in order for them to cancel. And so that means I need to use the bottom version. And so if I stop there, I would have hours. Now, when you're performing your calculation, you would have 0.084. You would multiply it, in this case, by 24. You want to keep extra significant figures if you decide to stop there because you don't want to round into the very end. My recommendation, set up your problem and carry out one long calculation. That way, you reduce the chance of an error as a result of rounding. And so if we're keeping track at this point here, our days would cancel and it would leave us with hours. And again, the second part was to go from the hours to the minutes. So I need my hours to now cancel. So since my hours are currently in the numerator, in order to get them to cancel, they're going to have to be in the denominator. So I want to choose the bottom version of this conversion factor. That would allow my hours to cancel, leaving me with minutes. So we now have our given unit, we now have the conversion factors that we needed, and we have them arranged so that those units that we do not need cancel out. So our days have canceled, our hours have canceled, and so once we carry out this calculation, we would be left with minutes. The way you calculate, again, everything that's up top, you multiply. Everything that's on the bottom, you multiply. You take the product of your top, which is your numerator, divided by the product of the bottom, which is your denominator, and you would have the answer. So when you put this in your calculator, you're going to have 0.0084 times 24 times 60. And so your calculator is going to give you 12.096. It won't show you the units, but your units are going to be minutes. But keep in mind the rules for significant figures. We have to use the measurements that are provided because even though we have these two conversion factors, those are exact numbers. They do not count towards our significant figures. So we were only provided with that one measurement, which was 0.0084 days. It only had two significant figures, so we would round to two significant figures and report it as 12 minutes. So again, we have identified the given and the needed units. We've identified how to go from those given to the needed units. We've identified the conversion factors that needed to assist this process. We've arranged them. We solved, calculated, we rounded to determine that 12 minutes is equivalent to 0.0084 days. So we'll do another example and explain the process of solving dimensional analysis. So here you're asked to convert 269 milligrams to kilograms. So again, you want to identify what's given. What we're given are the milligrams, and what we need are kilograms. So then we want to ask ourselves, is there a direct relationship between the milligram and the kilogram? Technically, there is a relationship. However, this can cause some issues for a lot of students trying to look at how these two different prefixes are equivalent. So my recommendation, when you're going from one prefix to another, treat it as a situation where you need multiple conversion factors. Because my recommendation is to go back to the base unit. That way, if you know the meaning of the prefix, you can simply use that as your conversion factor instead of trying to do a conversion within a conversion to figure out how many milligrams are in a kilogram. But instead of going straight from milligram to kilogram, if you go to the base first, so we go from milligram to gram. We can then easily go from gram to kilogram. It may give you an extra step, but it reduces the chance of a mathematical error by trying to go from one straight to the other. So I'm going to treat this as a problem that utilizes multiple conversion factors. And so we have our given, we have our needed, we now have our map or our plan. We can then do the conversion factors. We know that milligram to gram, we can do it two different ways. Again, I'll just focus on how many of the smaller are in the larger. And so milligram to kilogram, milligram is smaller, it's 1,000 times smaller, meaning that it's going to take 1,000 of those milligrams to make up 1 gram. Or I could have flipped it and showed it the other way. 1 gram for every 1,000 milligrams. Then you have the second part, gram to kilogram. Kilogram is the larger one, so it's going to take 1,000 of the smaller, which in this case is the gram, to make up one of the larger, which is the kilogram. Or I could have flipped it the other way. 1 kilogram for every 1,000 grams. If you prefer to use the meaning of the prefixes, then you can do that as well. I'll just go ahead and show it since I'm talking about it. What I mean by that is you would have your prefix, so 1 milligram. Milligram is the prefix. You would have the meaning on the opposite side with the base unit. Milli means 10 to the minus 3, and so you would have it that way. Either way works. You're going to get the exact same answer regardless of whether you do it this way or the way that was shown above. You just have to remember this way, the scientific notation way, the meaning of the prefix goes with the base unit. And so from there, we can then set everything up. We're starting with our 269 milligram. I'm going to do my T-chart, then use my first conversion factor. I'm starting with the milligrams, so I need milligram to cancel so that I can go to the gram. So again, this is where my first conversion factor comes in on my map, milligram to gram. I need to get rid of the milligram, so I need milligram on the bottom to go to the gram. So that eliminates this conversion factor, which leaves us with this conversion factor. So for every 1,000 milligrams, that's the same as 1 gram. At that point, my milligrams have canceled. Now again, I like to go ahead and do one long setup, so I'm going to demonstrate that process that I'm referring to, and then do my calculation at the end. So now I'm on to the second part of my plan. Now I need to go from gram to kilogram. So I need to get rid of my grams so that I have the kilogram. And so looking at that, what that tells me, I need to not use that conversion factor, but I need to use the second conversion factor. So I need to use the conversion factor that allows me to cancel my grams so that I'm left with the kilogram. So at that point, my grams have now canceled. And so when you're carrying out this calculation, again, everything that's in your numerator, 269 times 1 times 1, so you would end up with 269. Then in your denominator, 1,000 times 1,000, so you would end up with 1 million. And you take the product of your numerator, the 269, divided by your denominator, that 1 million, and then that's going to give you your answer. I'm going to write it a little sideways so that I have room. So you end up with 0.0000269 kilograms. So what this tells us is that 269 milligrams are equivalent to 0.000269. Excuse me. 0 Sorry, let me rephrase that. 269 milligrams is equivalent to 0.000269 kilograms. And so, again, this is how you go through the process of utilizing dimensional analysis. So I hope this helps. Feel free to reach out with any questions if you still have any. Thank you.